VLSI stands for Very Large Scale Integration. It is the process of integrating thousands of transistors on a single chip to achieve a particular functionality. It is a generic term referring to a chip with more than 20k transistors. For designing such kind of chip, we begin with design definition in the form of RTL, Register Transfer Language, then convert the abstract level definition into actual logic gates, and then proceed with manufacturing. This is certainly not a case where we have 4 or 5 components, we connect them on a breadboard and be done with it. So here we are talking about thousands of components. To handle such large scale design, we require specialized tools called EDA, Electronic Design Automation Tools. These tools provide end-to-end support for IC design, verification and validation. Most of these are commercial, with major vendors being Cadence, Synopsys, etc. Now we come to the question, why VLSI? Why do we need it? In 1965, Gordon Moore projected that the number of transistors in an IC doubles about every 2 years. This law has been holding true for past few decades. Let's try and understand this with an example. On the left, we have Intel 8086 IC, widely popular in the 1970s. On the right, we have Intel i5, a common processor in modern laptops. Comparing these two, we'll observe that transistor count increased from about 30k in 8086 to 500 million in an i5. This is an increase of more than 1,000,000%. Clock speed has increased from few megahertz to gigahertz, which is more than 100 times increase. To handle such exponential growth, we require major advancements in the field of VLSI. Another interesting point to note here is that even though we are increasing the functionality of a typical IC, there are size constraints, and we definitely cannot afford an increase in size. That's why technology is developed at a greater pace to accommodate such tight constraints. If this hadn't been the case, we would still be having our PCs occupy an entire room, which would definitely have been very disturbing. So in all, the main point is that to keep Moore's law alive and to keep having smarter devices with reduced size, VLSI tech needs to advance by leaps and bounds. This is the cause for increased focus on this field by almost all the countries. This is it for this video. Do like and subscribe and stay tuned.